as a part of the playlist SQL for beginners. In this video, I will explain the next most important concept, that is the constraints. The purpose of constraints is for accepting valid information. Constraints are divided into two categories: integrity constraints as well as the referential integrity constraints. Under integrity constraints, there are three constraints. The first one is the not null, and second one is the unique, and third one is the primary key. If you are applying not null constraint on particular column, that column won't accept the null values. Let us take, previously we have created a student table. There the attributes are roll number, name, class, date of join. While inserting the records, if you are not giving any information for any attribute, even in that case the record is created. That is invalid situation. For example, I try to provide the information only for name and then class. I am not providing the data for a roll number as well as the date of join. So the record is created. To control such type of things, you can use a not null. And the next one is a unique constraint to control the duplicate values. For any database attribute and database tables, there is certain key attributes. Key attributes in the sense, based on that attribute information only, you try to access the information. For example, if I'm talking about the bank account details, the key attribute is account number. If I'm talking about any product sales information, the key attribute is a product number. If I'm talking about the student, the key attribute is the roll number. On such type of attributes, you can apply this unique constraint. That means, once you can apply this unique constraint, it won't accept the duplicate value. That means, whatever the roll number which is allocated for the particular student in particular class, same number is not allocated for another student. And primary key, to establish the relation between the tables. What is the need to establish the relation? That I will explain with the help of simple tables. Let us take, there are two tables. Here, if you want to work with this primary key, first of all, you have to identify which one is the parent table, which one is the child table. So based on the information, let us take, there are two tables. One is the account master. In this table, I'm going to insert the persons who are opening the accounts. And the second table is account transactions. In this table, I'm going to insert those who are performed the transactions. If there is no relationship between these two tables, what happened? Without opening an account, it's possible to maintain the transactions. Is it valid or invalid? Definitely it's invalid. It's not possible. Without opening an account in the banks, it's not possible to perform the transaction. That's why between these two tables, I want to establish the relation. For this purpose, I can use the primary key. Primary key you can apply in the parent table only. How to decide? Either account master is the parent table or account transaction is the parent table. That depends on the key attribute information. On key attribute information, if the data is not repeated, automatically the table is called a parent table. In the parent table, on particular key attribute, you can apply the primary key. Automatically, the second one becomes a child table. That means, while opening an account, whatever the account number which is allocated for particular customer, it's not allocated to the another customer. Once you can open an account based on your account number, you can perform the transactions. While doing the transaction, your account number is repeated n number of times. That's why account transaction table is a child table. So like this, you can use the primary key. And come to the next one, referential integrity constraints. So here the first one is a foreign key. By using primary key, you can establish the relation between two tables. There you decide one table is the parent table and the another table is the child table. In child table, you can apply the foreign key. By using foreign key, you can establish the reference with the parent table. That means whenever you try to insert the records in child table, what happened? Each and every time it will verify with the parent table whether the number is available or not, whether the particular key attribute information is available in the parent table or not. If it is available, then only the record is created in the child table. Otherwise, it will display parent key not found. And the next one is on delete cascade. Once you can establish a relation between two tables, whenever you try to remove the records from the parent table, generally it's not possible to remove if the any child records are existed. For example, you are opening an account in a bank and you are doing some transactions. If you want to close the account, first of all, you have to clear all the transactions. That means you have to withdraw your amount, all those transactions you have to clear. Then only it's possible to close the account. So that is the situation. Now, the purpose of on-delete cascade is whenever you try to remove the records from the parent table, if any related records are existing in child table, to remove both the records simultaneously, you can use the on-delete cascade in child table with foreign key itself. And the next one is the check constant. Based on the condition to accept information, you can use the check constant. For example, while opening an account, the minimum balance is 1,000. If you try to insert the records less than 1,000, it won't accept. Same thing while maintaining the product information. So in my shop, there is no product which is less than 100 rupees. So minimum product cost is more than 100. Like this, if you want to implement the validations, then you can use the check constant. And come to the next one. The constants categories, two main categories. One is the column constants and the next one is the table constant. The difference between these two is applying the constant only on one column at a time. Only on one column at a time is called a column constant. And applying the constant more than one column at a time is called a table constant. Except not null, remaining all constants, you can apply it as a column constant as well as a table constant. For example, in my table, there are 4 attributes. Let us say, now I'm talking about the student table again. There are roll number, name, class, date of join. All these 4 attributes I want to apply column constant. You can specify individually. Roll number, it's a number, 4 digits, not null. Name, it's a varchar of 15, not null. Like this, you can specify individually. And table constant. At a time, you can't apply the constant more than one column. So not null is not possible. Remaining all constants you can apply. And one more situation where you can use the table constant is comparing the 2 columns which are existing in same table. For example, while maintaining the student information or while maintaining the employee information, let us say there are 2 attributes. One is the date of birth and the next one is the date of join. Generally, the condition is date of join is always greater than date of birth. In that case, you can use a table constant. That is one more situation where you can use. So that's all about the theory part of constants. The continuation, I will explain with the proper examples. So this is the continuation of the topic of constants. Now what's my requirement is, I want to create a table product with the different attributes, with the different validations. Here the attributes are product number, it's a number of 4, duplicate values not allowed, and the product name, it's varchar of 15, null values are not allowed, and quantity, it's a number of 3, negative values are not allowed, and the price, number of 4, and it must be greater than 100. So how it's possible how to create that, I will explain with the syntax. So I want to create the table product so that you can use syntax like this. Create table product. The attributes are product number. It's a number of 4. Duplicate values are not allowed, so that you can apply the constant, unique constant. And the next one is product name. It's a varchar 2 of 15. Null values are not allowed, so that you can use not null. And the next one is a quantity. Quantity, it's a number of 4 digits or number of 3 digits. Negative values are not allowed in this sense. That is a condition. Based on the condition, if you want to accept the information, you can use the constant check. Check. The condition is quantity must be greater than 0, so that the negative values are not allowed. And the next one is price. So price, it's a 4. Price, it's a number of 4. Condition is it must be greater than it must be greater than, it's also condition, so that you can use a check price must be greater than 100. That means if you try to give the equal to 100 and less than 100, it won't create any record. So table not the table created. Now we can describe the structure. Describe the table name is a product. So for not null only it will show, for remaining constraints it won't display. To check what are the constraints are created for this table, you can use Oracle system table called user underscore constraints. User underscore constraints. It has a n number of columns. So owner, constraint name, constraint type, table name, search condition, and our owner, that is the referential integrity owner, and then referential constraint name and delete rule. Like this, there are so many attributes. Out of n number of attributes, so you want to select only particular attributes. What is the search condition? Select constraint name, comma, constraint type, comma, what is the search condition? Search condition is in the sense, suppose we said that price greater than 100 and quantity greater than 0. Today we are creating the table. If any error is occurred, it's possible to remember. So quantity is must be greater than 0 or price must be greater than 100. After a few days, if you try to use the product table, you forget about these conditions. If you want to retrieve what is the condition or what is the constant you are adding to the table, you can use the select statement like this. Search condition from user underscore constants, where table name equal to, the table name must be in uppercase. The table name is a product, so it will display the constant name. It will display the sys underscore followed by C represents constant and followed by the number 11684. P name is a not null. So this is a not null constant. This is a constant type. And the next one is this is a search condition. Right? And the next one is one more constant, that is search condition is quantity greater than 0, price greater than 100. For unique constant, it will display the constant type as U. Remaining all it will display as a check constant. C for a check constant. Like this, it's possible to select. What are the constants are existing in a table. Now, to check whether the constants are properly working or not, I try to insert the values. I want to insert the table. I want to insert the records into the table. Insert into product. I want to check multiple conditions so that I try to give the multiple records so that I can use the ampersand product number and ampersand product name and quantity and the price. Ampersand price. So product number 111, it's a Pepsi. Quantity, I try to give the quantity as a positive, but come to the price, I try to by mistake I have given it as a 80. So what happened? It will display check constant violated. So along with it will display the constant name. Now based on this constant name, I want to get the search condition so that you can use the select statement like this. I want to display only search condition. Instead of displaying all the constants of the table, I try to use the constant name as a condition part, where constant name equal to that name we can use. That is a sys underscore C00111686. Sys underscore the Scott is a username and C00111686. It will display price must be greater than 100. You have given the price as 80 so that the record is not created. Now try to give product number properly. That is a 111 Pepsi. Quantity, I try to give the negative values. That is by mistake. Try to type it as a 40 by mistake. I try to type it as a -40. And this time I try to give the price as 140. Again it will display check constant violated. So again I want to check what is the search condition here. You can use the select statement like this, where instead of using 686, you can use the 685. So it will display quantity must be greater than 0. Like this, you can. Now this time I try to get the proper values for all the attributes. 111, it's a Pepsi. Quantity is 10 units, and each unit price is 120 rupees. Now the row is created. So anyhow, you can use the commit to save the data into the database permanently, right? Now, like this, you can, once the table is created, you can check whether the constant is properly working or not, so that you can give the values against the condition which was specified. See, suppose I try to insert the record like this. I try to insert the values only for product number, and then directly I go for quantity and then price. I'm not giving the value for product name. What happened? See, product number 112, quantity it's 5, price is 140. Cannot insert null values into the product name. Like this it will control. So like this you can insert the records. I try to give a duplicate values. Already one is there. Now this time you can give the product name as a Masa, and quantity is 6. Each quantity price is 130 rupees. So it will display unique constant violated. That means already 11 is there for Pepsi product. That's why it gives an error as a unique constant violated. Right? Like this, you can check with the tables, and while inserting the values, you can identify whether the connection is properly working or not. Now I have 2 tables. One is the account master and the account transaction. Between these 2 tables, I want to insert the records. I want to establish the relation first of all. So in account master table, the attributes are account number. It's a varchar of 5. There are 2 constants. One is a primary key and must be start with a AC. That means I want to insert the account numbers like this: AC001, AC002. Like this I want to insert. That's why it must be start with AC. And the next one is the name. It's a varchar of 15. Null values are not allowed, and balance, it's a number 8, 2 in this sense. Total width is 8, and 2 for decimal places must be greater than 1000. That means if you try to open an account, if you are giving the less than 1000, I don't want to create an account. That's why this is the condition. And the next come to the next table, account transaction table. Here the attributes will be like this: account number varchar of 5. It's a foreign key reference with account master, that is account number, transaction type, and it's a character of 1. Must be different characters. W for withdraw, whether it is lowercase, uppercase, I want to accept, and the next one is the deposit, D for deposit, and transaction amount, total width is 8, and 2 for decimal places must be greater than 100. That means if we try to perform the transactions less than 100 rupees, so I don't want to create a record in the account transaction table. For this, how it's possible, that I will go on an example with create the tables, right? Create table. The table name is account master. So you can use uppercase letters, lowercase letters, no problem. Once again repeat this point. So Oracle is not a case sensitive, but while comparing with the data, it must be case sensitive. If the data is in uppercase, you can compare with uppercase data. If the data is in lowercase, you can compare with the lowercase data. And create table account master. What are the attributes I want to maintain? First one is account number. It's a varchar of 5. Varchar of 5. The first one is a primary key, so that you can use the primary key. And one more condition is there. Constant. It must be start with the AC. Based on the condition, if you want to accept the data, you can use check constant. So what is the condition? Account number must be start with AC, so that to compare with the particular text pattern, you can use the like operator, check account number like AC percentage. So like this you can give. This is about the first attribute. The next one is account holder name. Account holder name. It's a varchar2, varchar of 15. So as in it's a not null. And the next one is the price. Price. It's a number of sorry, not price. It's a balance. Balance. It's a number of 8, 2. Total width is 8 and 2 for decimal places. Number of 8, 2. And condition. It must be greater than 100. Check. Price must be greater than 1000, not 100. If there is no invalid character. So here you can use the first like AC percentage. So beginning of the quotes is missing. And column check constant cannot refer. So here I am using balance, but in the constant check constant I try to use the price. That's why to give an error. You can overcome this problem. So it's not a price, it's a balance. So invalid character, this is one error missing, where account number like anyhow I try to clear the screen. One error is here, and it's a balance greater than 1000. Now the table is created. Like this you can create you can apply primary key. And second table is account transaction. Same way you can create table SCC trans. Here account number. It's also varchar 5. To apply the foreign key, simply can use the references. So references with what table, that is account master, with what attribute, that is the account number. References with the account number. And second attribute is a transaction type, T type in the sense transaction type. It's a character of 1. It's a character of 1. What are the different values you are expecting? So that you can use the check constant. To compare with the multiple values on single attribute, you can use the in operator. What are the different characters you are expecting? Uppercase, lowercase, both I want withdraw, comma deposit, and capital W, capital D. This characters represent a withdraw, deposit. And the next one is the transaction amount. Transaction amount, it's a number of 8, 2. Number of 8, 2. Here the condition is transaction amount must be greater than 100 rupees. That means if I try to insert the values which are less than 100 or equal to 100, I don't want to create check transaction amount. Transaction amount must be greater than 100. Missing left parenthesis. Here one bracket is missing. Transaction type in operator, and check. Here this entire expression must be in a bracket. So now the table is created. Now once you can list out the tables, account master, account trans. Now my concentration is like why I'm creating these two tables is I want to establish a relation between these two tables. That means whenever I try to insert the records in account transaction table, it has to check with the account master whether the account number is available or not. That I will show with the help of by inserting the records. Now insert into account master values. I want to insert the multiple records so that you can use the account number is varchar2, you must give within double quotes. That is the account number and account holder's name. Here you can use a name in the sense account holder's name, and the next one is a balance, so that you can use a ampersand to insert the multiple records balance. Now AC001, the name is Kiran and balance is a 5,000. Already I shown for init constants and then check constants. I don't want to concentrate on remaining attributes. Insert into the statement into is missing. Okay, no problem. AC001 Kiran, that is a 5,000. The row is created. If you are creating a primary key, it's for relationship purpose. At the same time, it won't accept the duplicate values and it won't accept the null values. Now, sorry, S002. It's a Rajesh, and the balance is 12,000. Second row is created. I try to insert one more record, AC003 Arun, and the balance is 8,000. So I try to give the commit command so that the commit complete. Now once you can select the data, select star from SEC master. So it will display. Now I try to insert the values for a account transaction table. Each and every time it has to verify with the main account master, because I given references account master of account number, so that they can use insert statement. I try to give a account trans. Account number is one attribute and another attribute is a transaction type. So transaction type and transaction amount, T amount. So try to give AC0001. Transaction type is again a deposit. Transaction amount is 2,000. One row is created. So again I try to give one more record. This time also I can give AC001. Transaction type is withdraw, sum of 1500. So any number of times the account number is repeated. So in the previous I told in a table on a particular attribute, if the information is repeated, the table is called a child table. In child table you can apply foreign key. If the values are not repeated, the table is called a parent table. In parent table you can apply primary key. Now you have to verify whether if you try to insert the account number which is not available in the account master table, what happened, you can check. So I try to give AC005. I don't know whether the AC005 is available in the account master table or not. By mistake I given, and try to deposit. The amount is 4,000. So it will display integrity constant violated, parent key not found. That means without opening an account, it's not possible to perform the transactions. That is the power of the important concept, constants. Right. Now in this previous this example, you are giving the primary key only on one column, that is account number. Suppose in case of joint account, what happened? It's possible to insert one more name for same account number. Because of creating account number, suppose I try to insert in the master table, I try to insert. First of all, you can check what are the records are there. Select star from SEC master. Now SEC001 Kiran is there. Suppose my situation is for a same SEC001, I want to make it as a joint account. In this case, what happened, if you try to insert the values, because if you are adding the primary key constant, it also main purpose is it's for relationship purpose. At the same time, it won't accept the duplicate values as well as null values. Insert into account master table, right? Account number, name, and then balance. For same AC001, there is one more person along with the Kiran, that is the Ravi, with the balance some 5,000. So unique constant violated. So this is a situation if you are applying the primary key only on one column. So to overcome this problem, you can create the primary key more than one column. So such type of primary keys are called composite primary keys. So that means I try to create primary key account number as well as the name. If both are same in a, suppose if I give the AC001 Kiran, again if you try to give the AC001 Kiran, that is a duplicate, right? So that I will explain now. So there are the tables I want to create. That is account ACCA mass and mass license master ACCTRA with the following attributes and conditions. The account number, it's a number of 5 primary key and must be start with the AC. And sorry, I don't want to maintain like this because it's a primary key. I don't want to start. I don't want to implement this condition because it's a number. I don't want to use this. And the name varchar of 15. It's also primary key. And balance, it's a number 8,2, it must be greater than 1,000. And the next ACCTR is another table, and it's a number of 5, foreign key reference with account master. So because of there are 2 primary keys, same also you have to repeat here. That is the foreign keys are account number as well as name, references with account master, account number, and the remaining 2 attributes are same as the previous tables. In this example, my concentration only on the composite primary keys. How to apply the composite primary keys? That is possible. So I will explain with the create table, SCC mass, account number, it's a number of 5, and next one is, so this is the table constant. That means you have to specify the 2 primary keys. So that you go for a table constant name varchar of 15 characters, and the next one is the balance. It's a number of 8,2, number of 8,2, and finally you can specify what are the keys are primary keys. Primary key within brackets you can specify account number as well as the name, close. So this is the way you can this type of primary keys are called composite primary keys. Now we try to create next table, that is a create table. At the same time what my requirement is, I want to go add the foreign key along with the on delete cascade. Foreign key with the on delete cascade. That means whenever I try to remove the records from the master table, I want to remove related records from a child table simultaneously. For this purpose, you can use on delete cascade. On delete cascade you can add with the foreign key itself. So foreign key itself now. So this is the SCTRA. Now account number, it's a number of 5. And name also have to mention because primary key is created on, that is a composite primary key. Composite primary key contains 2 attributes, that is a account number and the name. So foreign key also have to maintain 2 attributes, so that the name, it's a varchar 2 of 15 characters, and the transaction type it's a character of 1. It's a character of 1. Now this is a check constant, check transaction type in D as well as the W, and the capital it's also valid, and transaction amount it's a number of 8,2. This is also condition, check transaction amount must be greater than 100 or 1,000, whatever it may be. For previous account ACC mass, I'm not adding any constraint for balance. Why? Because my concentrate only on how to give the composite primary keys. That's why I have not given. It's no problem. And come to this one, check transaction amount. Here also you can remove. If you don't want to concentrate on a particular attribute. After this one, you can say foreign key. Foreign key. What are the attributes are foreign keys? Account number, comma, name or a foreign keys. References with what table? References SCC mass with what attribute? Same order you have to mention. That is account number as well as the name. Close the table. So this is a way how we can add a composite primary keys and composite foreign keys. Now try to insert the values. Insert into account master, not account master, ACC mass, that is an recent table. Account number is a number, so that you can use account number. And the next one is the name. I try to insert the multiple records so that you can use the name. And the next one is the balance. So 10001, the name is a Kiran, and balance is a 4000. So values are missing. So the keyword values is missing. SCC mass space values 1001. The name is a Kiran. The balance is a 4000. So it will display one row created. Now repeat 10001. There is another person, that is Ravi, with the balance 6000. So this is possible because you are creating a composite primary keys. When it's a duplicate, once again you try to give a 1001 with the Kiran or Ravi, then it's a duplicate. And I try to insert one more record, 1002. The name is Ajay. You can maintain a single record or it's a possible. Now there is no need to maintain the joint account. Maybe single record also enough. 8000. Once again I try to give. By mistake, if you're giving the 1001 again Kiran, this is a duplicate. Balance with the 6000. This is a duplicate. Unique consent violated. Clear? Now select the details. Select star from a ACC mass. What are the records are there? One giant account is there, one normal account is there. Now try to insert the values. Insert into ACC TRA, and after that you can give the values. Try to give multiple records. Even these names are not matching, the record is not created. Transaction type and transaction amount. So this is insert into. Now give 1001. Kiran was doing the transactions. That is withdraw from 2000. So it's created. So if the account number is which is not available in the account master, if you try to insert, what happened I have seen in a previous example. I'm not concentrating on that. And here what is the most important? I try to give the one more transaction for 1002. The name is Ajay. Transaction type is deposit, some 7,000. So like this you can insert. Now the next most important point comes into the picture is in case of previous account master and then account transaction table, while creating the foreign key, we are not applying on delete cascade. For not applying on delete cascade, what happens? See, I try to display the records from account master table. So there are the 3 records. And at the same time, I try to display the records from a account trans. There are the records. AC001 is there. Now, what's my requirement is I want to remove account master. I want to remove the record from account master where the account number is AC001, so that you can use delete from ACC master where account number equal to AC001. So integrity constraint violated. That means child records are found. It's not possible to remove. To overcome this problem, you can use on delete cascade. That you have to apply in the second set of account master table and then account transaction table. That is the ACC mass as well as the ACC TRA. Now display the records from ACC mass. And next one is the ACC TRA. Again repeat ACC mass, ACC TRA, the other records. Now what's my requirement is I want to remove the records from ACC mass, that is account number is 1001. So delete from ACC mass where account number equal to 1001. So here both the records are removed. That is a Kiran, and because that is a giant account, both the records are removed. At the same time, it will remove the related records by mistake or not adding on delete cascade. Okay. I try to foreign key. So in the previous case, while creating the table, I am not applying on delete cascade. It's the same. I'll do one thing. I try to drop the table SCTRA. Drop table. For it's not possible to add on delete cascade with foreign key itself. So you have to add with the foreign key itself. It's not possible to add on delete cascade individually. So that here I am dropping the table on account transaction. Once again I try to create create the table. Create table account transaction. Here we can give transaction type, because previously I typed the entire command. I don't want to type once again. That's why I'm using up arrow, down arrows. Foreign key, account number, references, account master. Here I have to specify on delete cascade also. On delete cascade. Missing keyword. On delete cascade. Cascade. Now the table is created. Now I try to insert the values. No problem. Use up arrow, down arrow. Repeat the same thing. Insert into account transaction. Values. Now I try to go 1001. Sorry. This is in order. This is 1001. Then want to do the transaction. That is deposit. Some 5,000. And one more record. 1002. Want to do the transaction. Ajay. Transaction type withdraw from 3000. Now these are the records. Select star from SEC mass. Select star from ACC TRA. Now what's my requirement is I want to remove the table previously seen. Without on delete case, what happened? it will display error message, child records are found. Now I want to delete from SEC mass where account number equal to 1001. 2 rows are deleted. Now check with the master table. It's removed. Check with the account transaction. That's also removed. That is use of a on delete cascade. Whenever you try to remove the records from the parent table to remove the related record from a child table simultaneously, you can use a on delete cascade. On delete cascade you can add with the foreign key itself. That's why I drop out the account transaction table and once again I try to create. That means with the foreign key itself you can use on delete cascade. It's not possible to add individually. So that's about how to use establish the relation between two tables and how to check with the data. This is one point. That means you can add the constants while creating the tables, and you can add the constants for already existing tables also. In this case, so you can use a add constant option except not null. Remaining all constants you can add by using add constant option with alter table. For not null you can use a modify. For not null you can use a modify. Right? So that I will show with the help. Now what's my requirement is, in a student table I want to add a unique constant for roll number. So once again go back and display the structure of the table student. There are different attributes. Check with the data. Select star from student, roll number 123, 124, 126. Here the condition is if you want to add the constants for already existing table, the table cannot contain any information which is against a constant definition. That means now what's my requirement is I want to add a unique constant to roll number in a student table. So in this case the roll number cannot contain a duplicate values. Then only it's possible to add a unique constant. Now check it. Roll number 123, 124, 125, 126, 127. There is no duplicates, so that it's possible to add a unique constant. So except not null, remaining all constants you can add by using a alter table, by using a add constant option. Now you are altering the table. The table name is the student. I'll clear the screen and go back to the top. Here I can use alter table. Alter table. The table name is a student. Your requirement is you want to add constant. So whenever the user try to add the constant, you have to give the name. So in case of while creating the table, system automatically generate the names. That those names are starting with the sys_c and followed by the number. Here you can give any name, but you can give some proper names to understand whenever the error is occurred. I try to give the abbreviation CQ in the sense unique on which attribute, roll number, what type of constant you are adding, add constant, constant name, unique, and on which attribute, that is a roll number. The table is altered. Now check with this table. Insert into student. I try to give the value only for roll number to check with this condition whether it is working or not. Values. Already 123 is there. Again I try to give same 123. Any constant violated. Right? So like this you can add the constant. Now for not null you can use a modify. Now what's my requirement is in a student table for name I want to add a not null constant, so that you can use a modify. Alter table. Table name is a student. Your requirement is you want to modify. So what is your requirement? S name. not null. Table altered. Now try to insert the record for student table, give roll number without duplicates. So give some 128. Cannot insert null values into the table or attribute as name. So the table is altered. So if you don't want to maintain all this, you can disable the constant. Here it will display any constant violated. It will display the name. If you don't want to maintain this constant on this table temporarily, if you want to make it disable, you can use a disable option. Alter table. Alter table. Table name is student. Disable constant. The constant name is UQ underscore roll number. So this is the advantage if you are giving the proper names, easy to understand what constant I want to manipulate. Alter table student, the spelling mistake, STU, table altered. Now once again we try to insert the value, duplicate values. What happened? Roll number. This time I want to insert a roll number as well as name because SNM is not null. I try to give a 123 again or 128 once again, and the name is Surendra. So it will disable the constant which are adding, that is a roll number, no duplicates. Now once again we try to add same unique constant on roll number. See what happened. Such unique or primary keys already exist in the table. That means already 128 is there. That's why unique constant is not adding. Now, so list out the table. Select star from student or select roll number, as name from student. So it will display 128. Alter table student, add constant. Unique already is there. 123, 124, 125, 126, 127, 128. So if there is no duplicate, it has to add. So I try to give the commit command, then only it will show. What is the problem here? I try to remove the record 128, delete from student, where roll number equal to (128). Now add the constant or remove the record student. So like this you can do the manipulations. So there may be some problem, that's why it's not showing properly. That I will rectify and come back to you. Like this you can add the constants for already existing tables. Permanently if you want to drop the constant, you can use the drop constant option. That means alter table, table name student, instead of using add constant, you can use drop constant name, that is a UQ underscore roll number. Table altered. Now this time it will accept the duplicate values. So now what's my requirement is the final requirement. I'll come back to the tables. Account master. Select star from SCC master. There are some records are there. There are some records are there. Generally what happened if you try to remove a record without on delete cascade, already have seen delete from ACC master where account number equal to AC001. What happened? Display integrity constraint violated, child records are found. In this case, what's my requirement is I want to remove the table even though some related records are existing child table without on delete cascade. For this purpose, you can use the command drop table name, that is a SEC master. If the records are generally, if the records are not possible to remove, we try to give a drop table SEC master. What happened? Unique or primary keys in a table referenced by foreign keys. So that is a problem here. So that even in that case, I want to remove the parent table. So the command will be like this: drop table SEC master followed by the option cascade constraints. Cascade constraints. Cascade constraints. SQL command not properly ended. Table dropped. Now check with the second table what happened. SU001 is there, but it will remove the records from it will remove that entire table from account master. The child table is not affected. It will ignore that existence of records in the child table. It will remove the parent table if you are using the option of cascade constraints. It's all about and one more final point is, if you are creating the new table by using an already existing table, what are the constraints are copied? So try to check, select constant type, search condition. So this constant type is enough. From user constraints, where table name equal to, I take where table equal to ACC mass, where table name equal to ACC mass. Now I try to check by creating a new table, create table SCCC mass duplicate as select star from SCC mass. You can check whether the primary key is copied or not. Now once again, instead of using ACC mass, you can use the ACC dupe. Nor selected. Primary key is not copied. Once you can create a new table by using already existing table. Now I try to create one. I try to check other regarding other constraints so that I can create a new table. Product dupe. First of all, I have to check what are the constraints are there. Select constraint type on a table product. Check constant, unique constant. If you want to understand properly, you can use a check constant. You can use a search condition also. It will display p name is not null, quantity greater than 0, price greater than 100, and a unique constant. Now I want to create the table product dupe as select star from product, as select star from a product. Table created. Now you can check what are the constraints are copied. Instead of product, you can use a product dupe. Only not only is copied. So that is the conclusion regarding constants. If any table contains all the constant except not null remaining or all other constants are not copied to the new table. Only not null is copied. Unique, primary key, check, and foreign keys, these constants are not copied to the new table. That's about the conclusion regarding constants.